All right, analyzing phase shift. Hopefully you've already watched the other notes about actually what is phase shift. The thing about this is, look at this first graph. This graph definitely looks like sine, okay? But they're trying to make it hard on you. And for the first two graphs, it says that we're gonna make this a cosine graph, which is a little annoying. Instead of saying that this is a sine graph with these characteristics, we're gonna have to just turn it into a cosine graph, which is not all that crazy. It just means instead of starting at 0 and going up, down, and making the snake shape, we need to start at the top and make the cosine cup shape. So, most of what we're focused on is going to be this shape here. Let's talk with the amplitude. Let me zoom in just a bit. Here we go. How high and low, what would the amplitude for this question be? 5. Yeah, we go up to 5 and down to -5. That also means it's easy that my vertical shift, 0.
What?
The vertical shift, 0. Think about it like this. Where is the middle of my graph? 0. Right? It goes down to -5, but that's the amplitude. That's probably just bad printer, I guess. I see what you're saying, but let's just trust it. These, I'm not sure what's going on with the copy machine, but it's struggling. Okay, now what about the period and the phase shift? The period is, how long does it take this graph to start repeating itself? Now, we could find any point, like maybe this, and just see how long does it take to do a full lap and get back to a point like that at the other end of the cosine graph. The problem is, I don't really know where that is. But we don't have to use the tops of the cosine. We can pick any point we want as long as we can see start and finish of a full cycle. So even though we're saying that this is not a sine graph, we can still check the period from here to here, because that still tells us how long does it take to keep the cycle going. So for this question, how long does that take? Pi. Nice job. So our period is pi. And lastly, our phase shift. There is a phase shift. Remember, we are a cosine graph. And the cosine graph is supposed to be here. But we got pushed to the side that much. And so what we're looking for is, how far is that? It is pi over 4. And then, like I heard somebody say, we need to decide, is this positive or negative? When you move to the right, it's always opposite, negative, because we moved to the right. Now, coming up with the function here, we're putting all this together, it can be legitimately pretty tricky, okay? What we're thinking about is that with a cosine, a number can go here. This is your amplitude. A number can go here. That's your vertical shift. A number can go here. That's your B value, which is related to period, but it's not your period. And then a number can go here. And that's your C value. That's your phase shift. So, we need to put everything where it needs to go. Jaleel's feeling good. What do you got?
I got 5.
Okay.
Do cosine of 2. And then parentheses x minus pi.
This would be an amplitude of 5, a period of pi, and a phase shift to the right, pi over 4. Beautiful. Nice job. Sure.
No.
Sure. Classic 1 o'clock bathroom, man. The man's on a schedule. All right. Lord, please. There's only a couple questions left, man. Gotcha. All right. We got a question over here. And something that I told you about phase shift is that it's kind of rare. It doesn't happen all the time. If we want this to be a cosine graph, is there any phase shifting going on? No. The cosine is right where it's supposed to be, right? It's starting at 0, right where we want it to start. So great. Already the phase shift is 0. This question should be easy. What is the period? How long does it take us to get from the start of a cycle to the end? 2 pi. Nice. That is easy. 2 pi is the standard number. Now up next is the vertical shift and the amplitude. Again, I like to do the vertical shift first. Find the middle. Where is the middle of our graph? The middle of our graph is at 1. Now, how high do you have to go to get up to the top? 2. Because you're going from 1 up to 3. A lot of the time, people who try to do amplitude first are going to say that the amplitude is 3. But if it's 3, that means you need to be going down to -3, which we don't. So 3 is wrong. The amplitude is 2, and we're vertically shifted up 1. This should be a pretty easy function without a phase shift and with a standard period. It should be from 1 plus 2 cosine x. And that's it. No B number, no phase shift number, which is like C. I'm feeling pretty good. All right, we got 2 more. That's it, and we're done for the whole day. Push through, push through. We've got 2 questions here. Now they're switching it up on us. Oh. Come on, board, come on. The poor board is tired too, just like we are. No. Okay, you got it. I don't think it worked, but we're going on. Okay, these graphs want us to use sine. Okay. The first one is the harder of the 2. We need a sine. In order to pick a sine, we need to start at that kind of 0 spot. So I'm gonna pick this as the start of my sine graph. So that means I need a sine graph, and I have a couple other things going on. Does anybody know any of these pieces? What the amplitude is, what the period is, any of that stuff? That was too many at once. Sorry. Vertical shift is 3. We go up 1, 2, 3. Perfect. Vertical shift is 3. Easy. What else we got?
I think I'm wrong. Is phase shift 3 pi half?
Yes, honestly, if the printing wasn't so bad, you probably would feel more confident. Yes, 3 pi halves. Perfect. Anybody got the amplitude or the period?
The period is 6 pi.
The period is 6 pi. That's correct. Now the period is sneakily becoming like one of the harder pieces. I know we like to think of our sine as going from here to there, but when it comes to the period, we just need any 2 spots where it starts to reset. And so start at the top, finish at the top, 6 pi. Nice job. And lastly, the amplitude, 2. right? We're up at 3, 4, 5. We go up 2 more, so it's an amplitude of 2. Coming up with the whole function. Anybody want to take a shot? This is big. So in order to get the b value, we got to do this. 1/3. Now I got one problem with this.
What?
Our vertical shift is up 3, that's good. And our amplitude is 2, that's good. And our b value is 1/3, that's good. And our phase shift is to the right 3 pi halves, which is minus 3 pi halves, that's good. But there is something that's wrong.
What?
It is, you're right, I think it's Joyce who's saying it. It needs to be minus. Oh. The board, please.
We know what you said.
It needs to be minus because what we chose was our sine graph to start here, right? But that's not sine. That's negative sine.
Oh,
That's upside down from what it really is. All right. Again, this question is legitimately hard. If you can do even part of this question, you're doing a good job, okay? There's only one left, and this one is even easier than that one. I don't know, guys.
That's the answer.
The board is completely given up on us, so it's the weekend already for board, for sure. The problem with this one is that the printer is also really horrible. So let's just go through it quickly. What's the vertical shift? 0. It's 0, okay? And we need this to be a sine graph, and you know what? It already looks like a sine graph. I think we're pretty good. So what's the phase shift? 0. Here's where the printing kind of hurts us a little bit. It is, again, I know it's hard to read. It is 2 pi fifths to do our full period. And then how far up and down do we go? Again, the printing sucks. I think it's supposed to be 1/2. The bottom one looks like a 3 and the top one looks like a 2. I don't know, guys. The printer just gave up on us like the board did. To come up at the very end with this whole piece here, the vertical shift is 0. That's great. The amplitude is 1/2. It is a negative, so I'm thinking negative 1/2 sine. I do not have a phase shift. I just need to make sure I get this period and the b value right. 2 pi over 5. You are absolutely right. You guys are getting so good at math. Look at you guys. Keep, change, flip. Again, if you can follow along with that, you're doing great. Okay,